Hi, this is Mr. Urrego again, and we're gonna find the values of the basic trigonometric functions. Okay, now that we know from where or how do we got all these values on my unit circle, okay, now hopefully we have that clear. That's very important to have. Now is basically now the process is simple. As we know, we have 6 basic trigonometric functions, which are my basic two are sine and cosine, okay, of any any angle. From there, I got tangent, cotangent, cosecant, and secant, which I already explained those ratios in a previous video. All right. Okay. Like I said, my basic two are sine and cosine. We're working with the unit circle, so I'm going to explain. Let's do the 30-degree angle. 30-degree angle, 30-degree angle. So let's do 30 here. Okay, 30. All right. I know that my hypotenuse here is 1. From these dimensions, I know that my x value is square root 3 over 2. And that my y value is 1/2. Alright, so let's use the ratios. Let's say that cosine of 30 degrees is adjacent side. Remember SOHCAHTOA? So cosine is adjacent over hypotenuse. Okay, cosine is adjacent over hypotenuse. So cosine of 30 is adjacent over hypotenuse. Anything divided by 1 is the same thing. So I have cosine of 30 is square root 3 over 2 divided by 1. Anything divided by 1 is the same thing. So basically I can erase this. So cosine of 30 is square root 3 over 2. Oh my god. Which is this value. Let's do sine. And then I'm trying to prove a point in a minute, which I'm going to show you right now. Let's do sine. Sine of 30 is opposite sine. Let me see where's sine. Sine over here. Sine opposite over hypotenuse. Okay, sine is opposite of hypotenuse. So sine of 30, opposite, 1/2, over my hypotenuse, which is 1. Half divided by 1 is 1/2. So I just need to have 1/2. Okay, which is basically the y value. So as we notice right now, when I do cosine of 30, I got, look at here in the circle, I have square root 3 over 2. That's the value that I got. When I did sine, I have 1/2, which is the y value. So for my unit circle, and this has to be really clear, for my unit circle, which I am using, my unit circle, the x value is going to be related to the cosine of whatever angle you're doing. Okay, in this case I'm doing cosine of 30. So cosine of 30 will be the x value. Alright, same thinking. The sine will be the y value. Alright, so right now what are we saying is whatever, let me go back to this. Whatever angle I'm talking about, you look at the x value and that will be your cosine. You look at the y value and that will be your sine. And I just show you where was that coming from, because the hypotenuse is 1. So if I want to do cosine of 45, here we go. Cosine of 45. Cosine is your x. So cosine of 45. And I need space. Okay, let's do next page. Cosine of 45 is square root 2 over 2. Alright, I want to do sine. So for sine, I look at your y value. Sine, you look at your y value. So sine of this angle, 45, has to be equal to square root 2 over 2. So sine of 45 is square root over 2. Let's do cosine of 60. So I'm going to erase over here. Alright, cosine of 60, cosine of 60, cosine of 60. Now, I'm looking at this triangle, cosine of 60. Okay, your cosine is related to the x value. Your y is related to your sine. Okay, so if I do cosine of 60, which is this is the case, then I'm going to look at my x value. Cosine of 60 equals, let me see, 1/2. If I want to do sine of 60, then I look at the y value. So sine is square root 3 over 2. Sine of 60 is square root 3 over 2. Okay. And so on and so forth. Cosine of, let's do the quadrant angles. Okay. Cosine of 0. 0 is this angle. Cosine equals 1. Cosine of 0 equals 1. Sine, I look at the y value. Sine of 0 equals 0. So the sine is the y value, the cosine is the x value. Cosine of 90, look, cosine of 90 right now, this is my angle. So cosine, I look at the x, so cosine of 90 will be 0. Cosine of 90 will be 0. Sine of 90, let's see. So the sine will be your y value. It will be your y value. So sine of 90 equals 1. That's why we need to know all these coordinates, because once you know that, you know everything. Okay? So let's do a couple more and then we go with the other functions. Let's say I want to do, let's do a bigger one now, the other side. Let's say I want to do cosine of, I don't know, cosine of 135, for example. 135. So basically I'm done with the triangles. I don't need to do the triangles anymore because I already proved all these coordinates. I already proved every single one of them. Okay, I proved them already, so I don't need to do the triangles anymore. So now 135, where's my angle 135? Remember, you do it in standard form. Start from here up to 135. So this is your initial rate and that's your final rate. That's your angle. Now, my cosine of 135, I look at the x value, which is negative square root 2 over 2. Sine 135, I look at the y value, square root over 2. Done. Let me see, 210. Let's do 210. So I'm doing 210. There we go. 210 and see what happened in 210. So cosine of 210 and sine of 210. So I always start right there. Where do I end? At 210. So my angle and my angle. That is. So my angle is from here to here. Alright? So cosine of 210. I look at that value. 210 equals negative square root 3 over 2. That's the x value. Sine of 210. 210. I look at the y value. How much is the y value? Negative 1/2. Done. Alright? So that's what you do. We haven't done negative angles. Let's do negative angles, just in case you don't, just to visualize them. Let's say let's say I'm doing let's say negative 30. Alright, let's do cosine of negative 30. Now, you always start on the positive x axis. If you go in positive angle, you go, this will be counterclockwise, I guess. And if you're doing negative, then you're doing clockwise. So negative angles, positive angles. Again, you start on the same, on the positive x axis. Going positive angles, negative angles the other way. Alright? So if I'm doing negative 30, I just start the other way. I don't start this way, I start negative 30. Negative 30. Because if this is 330, 360 minus 3, that will be 30 degrees. So that's my negative 30. So my cosine is square root 3 over 2, according to these coordinates that I'm looking at. Alright? I'm looking for my sine. Sine of negative 30. Then I know that's my negative 30 degree angle. My sine is negative 1/2. Okay? So that's basic, how to find the cosine and the sine. Now, the other trigonometric functions are depending on cosine and sine. Okay? So, let's work on this. Okay, now, let's work on the other trigonometric functions. Now, let's work with 30, for example. I have cosine of 30 is equal to square root of 3 over 2. Sine of 30 is the y value, so it's 1/2. Now from here, I just need to do my identities. Okay? Tangent of 30. Tangent is sine over cosine, so it's sine of 30 over cosine of 30. Okay? So tangent of 30, sine over cosine, 1/2 divided by the cosine is square root 3 over 2. Okay? So basically from there, I just need to do math, basic math. I have a fraction over a fraction. Okay? I show my students a simple process, which is the first term on the top times the last the last value on the bottom. So 1 times 2, that goes on the top. The middle two, the denominator from the first fraction and the numerator from the second fraction, the middle two multiply each other and they go on the bottom. Okay? So when you divide 1/2 divided by 3, square root of 3 over 2, then you get 2 over 2 square root of 3. Alright? You reduce that 2 and that 2, and you get 1 over square root of 3 over 2. I'm sorry, square root of 3. Now, can I have a radical denominator? No. So you need to rationalize the denominator, which is multiply times the same square root of 3. You're going to get on the top square root of 3 over square root of 9, which is going to give you square root of 3 over 3. So tangent of 30 is equal to square root 3 over 3. I want to find the cotangent. Okay, but what's cotangent? So let's do cotangent of 30. Cotangent of 30. Cotangent of 30. So cotangent is either 1 over tangent of 30, or if tangent is of 30 is sine over cosine, basically you flip those two, so it's cosine over sine. Okay? So again, cotangent as an identity is 1 over tangent, or cosine of 30 over sine of 30. Okay, so whatever is easier for you. You have already this value. You have tangent of 30, which comes from over here. So you can replace that. Or you can use the original cosine and sine of 30, which we have already here in the top. Okay, so either one of them. So let's do cotangent using the original 2. Okay, you can use either one of them, like I said before. So let's do cotangent of 30, and I said that it was cosine over sine. So it's cosine of 30 over sine of 30. Cosine of 30. Cosine of 30 is square root of 3 over 2 divided by sine, which is 1/2. According to the math that I just showed you, how to divide fractions, easy. You take the first one on the top times the last one on the bottom, and they multiply and they go on the numerator. And then you take the middle two and they go on the denominator. You reduce, and your cotangent of 30 is equal to square root of 3. Done. So we have sine, cosine, tangent, and cotangent. Same way we do secant and cosecant. Secant and cosecant. So let's erase this for a minute and let's work on secant and cosecant. Secant and cosecant. Now, everything depends on sine and cosine, and the sine and cosine you will get it from the unit circle. When I do identities, I explain simple. So you have sine. Let me write those real quick. You have sine, you have cosine, and you have tangent. That's your original 3. Then here on the side you have cosecant, secant, and cotangent. Okay? Now, how can I relate this 3 to my previous 3? One is obvious. Tangent will be related to cotangent, and that's the reciprocal cotangent. Now, for the other two, I noticed that one starts with S and the other with C, the same as the reciprocal ones, S and C. So my thinking is, you go opposite letter. So you do in sine, the reciprocal will be the opposite letter would be cosecant. If you do cosine, then I do the opposite letter, which starts with an S, and I do secant. That's how I think. I don't know if this works for you. It works for you. So tangent and cotangent are straightforward. Sine starts with an S, so the reciprocal will start with a C. Cosine starts with a C, then the reciprocal starts with an S. Alright? So when I'm looking for cosecant, in this case of 30 degrees, I'm going to do 1 over sine of 30. When I look for secant, if I'm looking for secant, then I'll do the reciprocal or of the cosine. So secant of 30 is going to be 1 over cosine of 30. Okay, and make sure that you don't have a radical denominator. That's it, basically. So let's do one at a time. So I show you that one, and that's the process that you do with every single one of them. That's the process that you do with every single one of them. So cosecant of 30 is 1 over sine. So cosecant of 30 is 1 over sine, but sine, we said that it was equal to 1/2. 1/2. Now I have a whole number divided by a fraction, so I make that whole number into a fraction. And I take the same principle, same thinking. Top, very first term, times the last one, and that goes on the top. The middle two values multiply and they go on the bottom. So cosecant of 30 is equal to 2. Secant, now I'm thinking 1 over cosine of 30. 1 over cosine of 30. Let's go to see what's cosine of 30. Cosine of 30 is square root of 3 over 2. So square root of 3 over 2. Same principle. Make that a fraction. First times last. That gives you a 2. Middle 2. That gives you a square root of 3. Now, technically that's your answer. But I'm not allowed to have a radical on the denominator. I need to rationalize that. So I multiply by square root of 3 by square root of 3. And I'm going to have at the top 2 square root of 3. And on the bottom is square root of 9 which is going to give me a final answer as 2 square root 3 over 3. And that will be your secant of 30. Okay? So, to recap, you have sine and cosine straight from the unit circle. Then to find tangent of whatever angle you do, it will be sine of that angle over cosine of that angle. Okay? You replace, make sure there's no radicals. Your cotangent, there's two ways. You do 1 over tangent of the angle, or you do the opposite of this, which is cosine over sine. Then we have secant. Like I said, think of the other letter. So secant is opposite to cosine, so it will be 1 over cosine theta. The last ones we have 1, 2, 3, 4, 5. Number 6 will be cosecant. Start with the C, therefore the reciprocal start with the S, so it's going to be 1 over sine of theta. And that's how you find your 6. So the main thing is to know the unit circle. You need to know the unit circle. You need to know these coordinates, because that's going to give you the cosine, which is the x, and it's going to give you the sine, which is the y. Okay, of any angle. I show you already how to go around the circle. So I hope this is going to help you out. And that's how you find the 6 trigonometric functions of any angle. Now the only difference now that is I've been working with the degrees, because as you're familiar with, later on the only difference now is instead of doing cosine of 30, I won't ask you about 30. I will ask you about cosine of pi over 6. Is it going to change? No. Why? Because instead of giving you degrees, I'm giving you in pi radians. So my answer stays the same. Square root 3 over 2. Okay? Instead of giving you, let's say, instead of asking you for cosine of 60, which is 1/2, alright? Look at this. I'm going to be asking you for cosine of, let me see what the dimension is, pi over 3. There we go. Am I changing the dimensions? No, I'm not changing anything. I'm just changing the units. So we need to start thinking in terms of pi radians. Alright, and that goes all the way around it. So all the conversions that I just did, on all this, everything in terms of the degrees, I'm going to be working in pi radians. So look at this, that 45, instead of the 45, I'm going to be asking you for pi over, and hopefully you're thinking right now, 45 is pi over 4. Is this going to change? No. 45, no, not 45, it's going to be pi over 4. 60, no, it's not 60 anymore, it's going to be pi over 3. Good job. 60. Okay, I hope you're getting the point. It's not 60 anymore. It's in pi radians, which is pi over 3. Let's keep going on the same thinking. 90. What's 90? Yes. Pi over 2. Another 90. Pi over 2. So instead of degrees, we're going to be working all of it in radians. 0 degrees is the same as 0 radians, so it's the same thing. Okay? Or 360, which is 1 full revolution. Okay? So let me erase those 30s. 30s. No 30 anymore. What's 30? It's pi over 6. 30. 30. It's pi over 6. Pi over 6. If you notice, I'm not changing the answers. I'm only changing these angles. That's all what I'm changing, the angles. Instead of giving you degrees, I'm giving you in terms of pi radians. Pi radians. Okay? So that's the most important, well, not the most important thing, but that's one thing that you need to keep in mind. You need to change your thinking from degrees to pi radians. Alright? That's a process that is not easy, but we need to do it in order for you to be successful in pre-calc or later on in calculus. Study please. Have a great day.